Privacy enhancing techniques. Some additional tools and techniques that can be applied on your personal information when being stored on file servers and databases to ensure that for hackers it is even more difficult to access and use them. Welcome to my YouTube channel. In this video we are going to talk about various privacy enhancement techniques. What are these techniques? These are tools and techniques that help you protect your personal data in a better form. Actually, it is the collector agency who has collected your personal information for processing that they can apply these tools to enhance privacy. Very basic of that is that you minimize the collection so that minimum data and only relevant data is collected and processed. Ensure confidentiality that you can do through unauthorized user access also. But make it more safe by using these techniques when the data is stored on your systems. It could be your handhelds, it could be your mobile phones or your laptops or even the servers where your agency that has collected your personal information is storing the information. It definitely helps protecting you against data breaches through these additional digital services. Let's look up at some of them. The very basic one is encryption. Right? You encrypt your data, you store your data in a coded form, and it can be decrypted or it needs to be decrypted if you want to read it. Right? It has to be decrypted using the same tool. You can have a symmetric encryption or an asymmetric encryption. In symmetric encryption, the encryption and decryption keys are same. The key that is used for encryption, the same key is to be used for decryption, right? Like the standards like AES standards of encryption, they use the same key for encryption and decryption. So if you are able to get hold of the tool that used that encryption as well as the key, then but then these two information you need if you want to read that data. But then there is an asymmetric encryption also that are followed with the RSA standards and all, where the encryption key and decryption key are different. There is a different key deployed when you are encrypting your data and a different key used when you are decrypting your data. So with the additional security that the keys are also different, the data is even safer. That's the very basic type of encryption that we have. We have a slightly advanced encryption which is homomorphic encryption. You encrypt your data and then the homomorphic encryption tool does some computation on that data. So the final stored output is a computed encrypted data. So two layers of protection. It is first encrypted, then a computation layer put on it and then stored. Right? So when someone even steals that data or has an access to that data without the tool used for homomorphic encryption, he does not know the computation algorithm, he does not know the decryption key, so he cannot just access the data, read the data, or then of course he can't use it, he can't misuse it also. Right? So it is very useful when you are securing data on cloud. Then we have a privacy preserving data mining technique where you extract all the information from all the useful information from your data sets. Now in our case the useful information is PII, the personal information of the user whose data is being stored. So you extract it and anonymize it. Put in some other tools, put in some other words or some other algorithms so that on a visibility part it looks like complete data, but if when someone tries to read it, he does not get the full data because he does not know where all have you removed the PII and put in a wrong data. Right? This is similar to what you also call as anonymization, where you remove the PIIs and instead of PIIs you put some different data blocks over there. So when someone is able to access the data, take it out of the system, if he does not have the same anonymization tool, he cannot open the data, he cannot identify the data. Even if he is able to identify a part of the data, but since PIIs are not with him, then he cannot link the data as to whom does this data actually belong. Something similar to anonymization is pseudonymization. Pseudonymization, you remove the PIIs, but you replace them with pseudonyms, similar names, right? So in anonymization, you use a different range. For example, there's a data block saying 10th of August, and instead of 10th of August, you write over there 10, right? So that could be anonymization. But when it comes to pseudonymization, you replace 10th of August with say 10th of July or 10th of September, any other similar date. So the relevance of the data would not be available when the user gets it. Maybe you can use a synonym against August, which may not be the month, right? And similarly a synonym against 10, which does not need to be a number, right? So 10 could be pen. So in that case, no one can open up and say, what does this mean, right? So that way you are replacing your PIIs with pseudonyms, and therefore people are not able to link it with the actual user. Then for your mobile devices, there is a federated learning system. Remotely data sets would be processed. It happens on our mobile devices. This technology is used for multiple decentralized devices. The data is processed remotely. Data does not travel. So the machine learning algorithms process data from different devices, but they do not collect the data. Right? Since the data is not traveling on the wire, the data is safer. So risk of traveling on an exposed internet bandwidth is reduced, and the entire data is processed remotely while it continues to stay on the mobile device only. Right? And mobile operating system companies do such processing while processing the data on the apps to ensure that your data does not move out of your mobile device. Then you have secure multi-party computation. The data is there, the PIIs are there, many people need it. Instead of many people and distributed PIIs and distributed data, the data is kept at a central place. And all the agencies, through their algorithms, are allowed to access the data, process, and get the outputs. The inputs remain private. The inputs are not shared across. Collaborative analysis can be done, but output can be shared, input cannot be shared in these cases. Right? So competing firms or joint collaborative research can be done on common data through different algorithms without again moving the data out, without sharing the actual PIIs. It could be a healthcare data, for example. Right? So you have collected sample of 1,000 patients. You don't need the detail of the individual patient. You just need the output of the maybe a test done on those patients. So multiple agencies can work on those outputs, and they don't work on the PI of which report belongs to which patient and what are the personal details of those patients, right? So see, the one who is planning a medicine, the one who is planning a treatment, the one who is just analyzing that how many patients are there, they all can work independently as well as collaboratively, but they don't need to, and they don't even have an access to the PIIs stored in that particular information. Another one that we have is a differential privacy, where a random noise is added to your data sets. This is largely done when it is important that you need to pick up the data and push it remotely for some analysis. So a random noise is entered or added into your data sets before picking them up from the source device. And because of this, the PIIs get suppressed. Right? So US Census Bureau uses it. Apple uses this to understand which of the emojis are more in use. They add noise on their devices and collect the data. They come to know which are the emojis used in this device. They discard the remaining data, collect millions of such data, and then they know which emojis are more popular. Because the target is to know which emojis and which type of emojis are more popular and not who is using it. Right? So it is safe that your personal information is not even disturbed or picked, so the chances of privacy breach in this differential privacy is also reduced. What are the benefits of that? It's enhanced data protection, it helps you meet regulatory compliance, GDPR, HIPAA, CCPA, so anything that is putting an additional check that your personal information is not getting leaked, no one can misuse it, is a benefit for you, because you are talking of the breach of your personal information. It enhances the user's trust. If I know that Apple picks up my emoji details but with noise entered into it, then I would trust the operating system more, right? So the user trust is increased, and of course these are innovative technologies, not so easy to hack or break and access your personal information. There are some challenges as well, right? So new technologies, complexities, cost, resources, you need more resources, they are expensive ones, but then the kind of user trust they bring in, the kind of reputation that brings in for the company who is collecting the data for processing is tremendous, right? The cost of a breach, which may happen very rarely, could always be far more than the cost of any technology that would have avoided the breach. So it is very important to see if the technology is usable and what is the sensitivity of the personal information that you have collected. What could go wrong with the breach of that personal information, how expensive it could be for your organization, and accordingly you can balance out between the privacy risk and cost and the complexity of usage and choose one of these privacy enhances technologies for your personal data that you have collected. That's what I had on privacy enhancing techniques. Thank you very much for watching the full video. Please subscribe to my channel to stay updated on content on data privacy, and please press like and bell button so that I stay motivated for uploading new content on a daily basis. Thank you.